Hello class. In this video lecture we are going to discuss about the MOSFET and UJT. Before that we will take a quick review of operation of GFET. GFET stand for junction field effect transistor. We know the construction that we take a slab of, let's say, N type, then oppositely type means P type bars are created over there and they are internally connected so as getting the terminal called gate, and on the same bar of N channel, that region between these two bars of a P type material we call channel. From the channel we getting the drain and source terminal, as the FET having three terminal, gate, drain and source. And about the operation, it is easy to remember as that when both the voltages, that is voltage applied between the gate and source and the voltage applied between drain and source, both are at minimum level, let's say 0 level, then the current passes through the device called the drain current, which actually passes from source to drain, but conventionally we said it is flow from drain to source. It is maximum. But if we keep a voltage between drain and source, actually drain and source are both drawn by a same type of a material. That is, if you are talking about the N channel, that means from the N type only we drawn drain and source. If you make a constant voltage across the drain and source and we further decrease the reverse bias across the gate, then the depletion layer across the gate will go on increasing, and a voltage level that found, it must reach at maximum level pinch off. That is, either side the depletion layer goes on increasing and no current should be flow within this condition. That voltage is called pinch off voltage. It may be denoted by VP, VC or VGS off, cut off, like that. So to make it on or to flow a current through it, if we wish so, then we have to maintain the gate voltage in such a manner that it must be less than a pinch of voltage. That's why we go on increasing the drain voltage, that is a drain terminal become more positive as compared to the source terminal. In such situation, controllable current should be flow within the channel, which is due to the majority charge carrier. As we know that in JFET, current flows only due to the majority, and this current called drain current is controlled by a voltage applied across a gate terminal. That's why this FET category or JFET called voltage controlled device. Okay, now we move towards the MOSFET. MOSFET stand for metal oxide semiconductor field effect transistor. Their classification broadly classified into two categories. One is called enhancement type MOSFET and second is called depletion type MOSFET. Again, these are each one having two types, N channel and P channel. In enhancement type of a MOSFET, there are again a two category or mode of operations as enhancement mode and depletion mode. MOSFET also called insulated gate FET, because if you see the construction of a MOSFET, then we can see that the gate is isolated by the structure. It means, as like in JFET, gate is not drawn by the material. Instead of that, there is a insulating layer deposited over the substrate. Okay, now principle of the operation, it is clearly, or it is pretty much similar or analogous to the capacitor or capacitance. Okay, I read these lines as a principle: by applying a trans-electric field across an insulator, that called the silicon mentioned in this name, deposited on the semiconductor material, the thickness and hence the resistance of conducting channel of a semiconductor material can be controlled. Okay, first we will see enhancement MOSFET, and then we will go for the depletion MOSFET. If you see the construction of enhancement MOSFET, then for that, if you're talking about the N-channel enhancement MOSFET, then we have to take a P-type substrate. Literally, we have to take a piece of a P-type silicon substrate. On that, two heavily doped regions should be diffused, and from that region, we can draw a terminal called drain and source. Okay, they are separated by some space. Again, after that, a thin insulating layer, that is SiO2 layer, is grown on that surface. Okay, and after that, the metallic contact drawn, which separate that substrate body to the terminal called gate. That's why it is called insulated gate. Okay, now if you see construction over here, then the idea might be clear here. N-channel enhancement MOSFET, that's why we are taking the P-type substrate over there to N-type doping levels, which gives us a source and drain. There is an insulating material lined over here, and after that the metallic contact called gate. Okay, the substrate is also called body. Okay, in depletion type of a MOSFET, particularly if you're talking about the symbolic representation, whenever we talk about the N channel, it means into the structure, or here we see that gate is insulated. Gate is insulated. There is a gap. That gap is filled with a SiO2 layer. Okay, like same JFET, drain, gate, source, terminal. These are also available along with a body or substrate is there. Okay, this is the circuit symbol and construction details are here. Okay, now in JFET there is a direct channel forming, but here due to this SiO2 layer, now we can say a gate. If you're talking about the operation or for clear understanding, gate terminal or the metallic contact over here, it analogous to the single plate of a capacitor, and next side or the substrate body over here, the space between this drain and source. Okay, this will act as a second plate of a capacitor. Now if you bias this MOSFET, that is if you apply a voltage between gate and source and drain and source, then we get the idea about the operation. If you apply the positive gate voltage, then it will be a enhancement mode of a operation, and if you apply the gate negative voltage across the across gate terminal, then it will be a depletion type MOSFET. Okay, now how the current flow through a MOSFET, if you're talking about that, then in depletion type current is as compared to or gate to source voltage controls. Here if a gate voltage is positive, then gate terminal or the plate side, the gate is accumulated with a positive charge, and the space between the drain and source, it is accumulated with a opposite charge, that is a negative charge. Okay, that's why it is called the enhancement mode. Here we get the drain current as a maximum. In depletion mode, if gate is negative, then obviously second the channel formed here is due to a positive holes, and the channel here is a N-type. It means the minority charge carrier are accumulated on the second plate, and that's why we get a drain current. Okay, symbolically representation already shown in the first slide, or here also we get that one. Okay, now the most familiar or most popular question is the comparison between the MOSFET and JFET. So JFET, there is a physical channel appearance, but we know in case of a MOSFET there is a inversion layer also formed. If you're talking about the enhancement type of a MOSFET, then there is no formation of a channel between the drain to source, but actually there is a formation of inversion layer. Okay, inversion layer. How it could be found? That in enhancement type of a MOSFET, gate is strictly connected to the positive terminal, or it must maintain the in a enhancement mode only. When the voltage gate to source voltage is 0, then the voltage between the drain to source tries to force the free electron from source to drain, but the presence of P region in between them, it doesn't allow to flow a current. Okay, so therefore no drain current flow when the gate is 0. To make it on, or to make it the device on, we have to apply a gate voltage positive. Okay, now we will see about UJT. Sorry, something is missing. I am inserting more than 2 slides over here, so we get a clear differentiation point by the syllabus or by the reference level. We are talking about the JFET and BJT class, BJT comparison. Then in JFET, current is only due to the majority charge carrier, but in case of a BJT, it is due to both the charge carrier. It means minority or majority. Okay, BJT is a current control device, and FET are the voltage control device, and JFET are the having low noise level. But in case of a BJT, the current constitute the minority charge carrier. That's why noise goes on increasing. It having a thermal stability at a very low points because the minority charge carriers are involved. But in case of a JFET, this drawback is overcome over here. Okay. Then the output to input ratio, that is a gate gain is gain is high in case of a JFET, but in case of a BJT it is smaller as compared to the JFET. Okay, now we will move towards the UJT over here. UJT stand for Unijunction transistor. Up till now we are talking about the transistor, and in transistor there are 2 junctions and 3 terminal device, but UJT is an exceptional case of a transistor in which there is only 1 junction. That's why it is named as a Unijunction transistor. As like transistor, it is having 3 terminal, namely emitter, base 1 and base 2. Okay, but like a diode, it is having only 1 junction, so the name is Unijunction, and having a 3 terminal, it is a transistor. It is a transfer and a resist. Symbolically, it is represented as like this one. The emitter drawn over here is somehow tilted, and it is inverted arrow. Okay, the equivalent circuit is shown here. UJT basically used to trigger or to supply the voltage for the SCR, silicon controlled rectifier. To trigger on, many of the devices used, but most popular device is a UJT to turn on the SCR. Okay. The basic construction of a UJT is seen over here, in which it consists of a N-type silicon bar, this slab is a bar, N-type, and P-type doping is done, from which we draw a emitter terminal. Okay, now there is a depletion layer formed here. When we bias a UJT, means if we provide a forward bias across the emitter terminal, which is heavily doped over here, while the base region is lightly doped. Due to this reason, the resistivity of the base material is very high. The terminal taken out from the structure as base 1, base 2 and emitter. Whenever the emitter is forward bias, more forward bias as compared to base 1, then this will be turned on. Okay. The point over here we have to remember is symbolic representation and construction. UJT is mainly used to trigger on the SCR. Okay, we will stop here.